Assalamualaikum, brothers and sisters. Are you there?
Yes.
Waalaikumsalam.
Okay, good. Should we start? Only 25 already in the class. Can we start?
Up to you, Doctor. I don't mind.
Okay, I will start. Okay, one more time. Assalamualaikum, brothers and sisters. Let's start our day with the recitation of Ummul Kitab Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi Rabbil Alamin. Ar-Rahmanir Rahim. Maliki Yawmiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, let's start our day with a recitation of a dua by Ustaz Aiman. Tafadhal Ustaz Aiman.
Bismillahirrahmanirrahim. Allahumma nawwir bil kitabi absarana washrah bihi sudurana wa sahhih bihi abdanana watlik bihi sinatina wa qawwi bihi jinanina wa asri bihi fahmina wa qawwi bihi azaimana bihaulika wa quwwatika fa innahu la hawla wa la quwwata illa bika ya arhamar rahimin. Allahumma stauda'naka ma alamtanahu fardudhu ilaina inda hajatina ilaih wa la tansanahu ya rabbal alamin. Amin.
Amin ya rabbal alamin. Shukran Ustaz. Okay, let's move on. We're still doing exercise. Want to run around? We can run around. Okay, this is what we did last class. Last class on this Mirama company, Maximax, Maximin, Minimax regret, who is criteria, equal likelihood. You are good at it already. Now let's move on to the next sub questions. So here it says if the probabilities of the market conditions are here 10% for favorable, stable. I think there's a number up there, I cannot see. There's a certain number. I think 70, 20, 70, 10, something like that. So now compute the expected value for each decisions and select the best alternative. So what should you do?
Multiply
Multiply with what?
the value.
The value of the probability.
Yes.
Okay. Okay, what's the probability of S1? S1 favorable demand
0.2.
0.2. Then the probability of stable demand 0.7.
0.7.
Okay, and what else? The last one 0.1.
Yes.
So let's put in the probability here. 0. I print again on the payoff here. 0. What was it? 0.2, right? 0.2. Here the probability 0.7 and here 0.1. It is best that you draw the second table, the lower one here. This lower one. You can draw this and then you can write we are going to calculate the expected value. You're going to write down the expected values somewhere here. Expected value. Okay. Tell me when you are ready. Just quickly write this one. Are you done? Okay, just quickly put this table. The lowest one. Or if you don't, then it is also okay. As long as you have two columns there. We are going to calculate expected value and expected opportunity loss. Ready? Can we move?
Yes.
Okay. Expected value, how do you
Yes, sir.
calculate? For the first one, 0.2 times
0.2 times 120,000 plus 0.7 times 70,000 plus 0.1 times negative 30,000.
so what do you get?
70.
70.
70,000.
70,000. I just put 70 here. Then for the next one, the hammer, the same
42.
way. Someone say what?
42.
42. Yes, 42. 42. Then the next one.
31. 31.
Oh, I got the wrong in the wrong. I put in the wrong row. Let me rewrite. This one first. Never mind. So we have 70. Again wrong. 70, 42, and the last one.
31.
You get some
31.
31.
31.
Okay, come to aspect. Yeah, okay, 31. So to expected value, which one to choose? Highest or
Highest
what?
one.
The highest one.
Highest one.
Highest. So what's your decision?
Reject.
Produce. Reject. Okay.
Reject.
Okay. Good. Okay, let's move on the next question. Develop the opportunity loss table and compute the expected opportunity loss for each product. Remember last class we calculate the regret. Do you remember how you calculate the regret? Now I reproduce here.
Yeah.
This is the one I reproduce. So this is the regret. This one, the regret. So now we are going to use the probability to compute the regret. So here 0.2. Here is 0.7. Here is the third one is 0.1. So let's calculate the probability, sorry, the expected value of opportunity loss. So what you do, 0.2 times 0 plus 0.7 times 0 plus 0.1 times 60. What would it be? So E O L. So I like to put V little bit here. It means it's not the same as regret, but this time we are multiplying with the probability. What do you get? 0.1 times 60.
6.
So 6. 6. The next one, 0.2 times 60 is 1.2 or 12.
12.
12 plus 6 plus 1.
19.
Hmm?
19.
90.
Uh,
Not 30 something.
34.
sorry.
I think 30 something.
34.
I heard
34.
somebody 34. Okay, 34. The last one. Sorry, wrong. Wrong. Okay, this one belong to this row. This one belong to this row. Okay. The last one.
45.
45. 45. So come to EOL. Which one do you choose?
Widget.
Widget.
Yes,
So we are going to produce widget. The data on the previous one is lost. If we calculate the, okay, doesn't matter. You take note of this EOL, the number 6. Oh, where's my cursor? You take this, remember this number 6, the lowest EOL. Okay, let's proceed. Now the company, what did it say? The company is trying to engage a consultant to determine the future market conditions. The result of the survey will indicate whether positive or negative market report or market conditions. There is a 60% probability of a positive report given favorable conditions. 30% probability of positive report given stable conditions. And 0.1 probability of positive report given unfavorable conditions. Okay, we stop here first. What does this mean? So if we were to engage a consultant, the likelihood of the report is positive or negative. Negative, maybe there is some error. Negative, positive, maybe less error. That means good.
Positive report.
Positive report. So let's say we put P stand for positive report, N for negative report. Doesn't matter, capital P or capital N. Just now we have three circumstances about if we don't have this report. We have favorable, we have stable, and we have another one, unfavorable market, the demand. So what it says here, there is a 60% probability of positive report given favorable conditions. The probability of, what does it say? The probability of positive report, that means the market condition is good, given favorable condition, favorable market. This is what it says. And then we have another one, probability of positive report given the second one, 30% probability of positive report even unfavorable, stable, stable condition.
Stable.
Okay, let's put stable first. So this is 0.6, 0.3, and then there's another statement, 10% of probability of positive report given unfavorable market or unfavorable condition. So the probability of positive report given unfavorable conditions. So what is the number? 0.1.
0.1.
And then the next sentence, it says there is a 90% probability of negative report given stable 90% probability of negative report given unfavorable conditions. What does it say here? There's a probability of negative market report given unfavorable market conditions. Where's the number given there? 0.9. And then next sentence, a 0.7 probability given stable conditions. So probability of negative report unfavorable. Sorry, this is stable. Wow. 0.4, 0.7, 0.7, right?
Oh yeah, 0.7.
0.7. Then there's another one, probability of negative report given favorable conditions. So that is 0.4. Okay, what are we going to do with these numbers? This is the conditional probability based on the market report. You look at this format. Sorry, I'm searching for my cursor. P and something. Yeah, and something. Now we are going to find what we call it posterior probability. Posterior probability, we are going to convert something like this as, sorry, say I take the small f, favorable over something, over P. We are reversing. Here, we are going to also change something. Let's say take the lowest one, U over N. So we are going to tabulate this. Remember the Bayes theorem? No, I cannot flash back. But now we just do a table. We need 5 columns. Okay, let me draw a line. Oh, straight. One, two. Okay. Be you prepare 5 columns. And I think you need both 4 rows. So the states of nature, we already have this information. States of nature, we have favorable, there are 3, favorable, stable, and unfavorable. Now, if we are we are trying to find the first set under positive market report. Under positive market report. Okay, I do slowly. And then we have the prior probability, which was 0.2 favorable, the older one, 0.2, here 0.7, and then the last one is 0.1. This is the prior probability. Now we are going to use this information, which I box up here. So we have the conditional probability here. I keep searching for my cursor. So the conditional probability.
Doctor,
Yeah.
for the prior positive and favorable, why is it 0.2?
This is based on the earlier one.
Oh, okay.
Sorry, we use this information, this from this slide, 0.2. Can you see 0.2,
0.7.1.
0.2, 0.7, 0.1? This is prior probability. Are we okay? Okay, we use this information. Then we are going to use the one I boxed up just now, probability of positive report under favorable, positive, favorable, positive, favorable. So positive, favorable, what do you have there? 0.6. 0.6. And then under the positive, stable, 0.3. 0.3. Okay, we write here. And the last one is 0. Now you are faster, you are 0.1. So what we do now, you calculate the joint probability. Sorry, not so, I cannot write so detailed there. Joint probability, you just multiply with the 2. 0.2 times 0.6, 0.12. 12, right?
Yes.
6 times 2, 12. Here, 0.21.
Yes.
0.21. Last one, 0.01. Add it up, the joint probability. What do you get? You add it up. You get 0.34, right? You get 0.34. So we refer this as the probability of positive report. Probability of positive report is 0.34. That means the likelihood of this positive report, that means with no mistake, is very low, is 0.34. That means you expect no error. The chances is only 0.34. Then now we are going to calculate what we call it posterior probability. Posterior probability. How do you calculate? This one divide by the total. Remember, the joint probability divided by the sum of joint probability. The lowest one is the sum of the joint probability. 12 over 0.12 over 0.34.
0.352.
0.352. Okay. You are very fast. 0. Are you getting somebody?
Yes, 0.617.
617 or 618. Last one, 0.02 something.
0.00. 29.
29. Oop, what happened? Where's my cursor? 0. What was it? 29. 29. So we have one set of posterior probability. This one, how to write? This is actually probability of favorable and the positive report equals to 0.352. Here become probability of stable and the positive report. Probability of unfavorable and the positive report. No space to write. Now you see the difference here. I am now at the box here. P over F here. F over P. We are actually changing from P over something to F over something. Instead of this one is dominant, now the smaller, this one is on the left hand side. So we do the same. We do the same for the second set. What is the second set? Negative market report. This is quite tedious. And do the same thing. I hope you are doing the same on your paper. Or at least you look at this, how we are doing it. So
Sorry,
here,
how to
yeah,
count the posterior?
posterior.
How to count the posterior? I didn't get that.
This one, the posterior. Okay, let's look into this one. Remember, see this one, 0.12.
Okay, yeah.
0.12 divide by 0.34. Divide by the same thing here. 0.21
okay.
divided by, okay, okay.
Thank
Good.
you.
Now let's do another set. What is that P there?
Doctor, both prior is the same, right, for both positive and negative?
Yeah, it's the same. We are using, let me erase this one first to rewrite. Sorry, I feel a little bit, not a little bit, very clumsy online. So this is the probability. Okay, now we are having negative report. We are going to calculate the same one. We are going to look into, see the lower one that now I'm boxing up. We are going to use this informations, this data, the same set. Just now, brother, I think the voice is brother Ayman's voice. The same set of prior probability 0.2, 0.7, 0.1. I don't write the here. This is states of nature, prior probability. Here is the the conditional probability. Here is the joint probability. Here is the posterior probability. Okay. Now, do we have the information here on the conditional probability?
Yes, doctor.
Yes.
0.
What do you have here?
0.4.
0.4. So you use this 0.4. The second one, 0.7. Now, yeah,
And 0.9.
now faster, 0.9.
Yes.
So calculate the same way, join joint probability, 2 times 4, 0.08.
0.08, yes.
0.08,
0.49
0.49,
and 0.09.
0.09. Then sum it up, total it up,
0.66.
0.66, 0.6, this is 0.66. So this total, actually the probability of negative report. So that means a likelihood, the report, I mean, quite a high probability, the market research have error there. This is how to illustrate to you. So let's calculate the posterior probability, the same thing. Take the joint probability, divide by the sum of joint probabilities.
The first one is 0.121.
0.121. Okay, I think that's correct.
0.742.
0.742. 0.742.
And last one is 0.136.
0.136. Okay, so this is actually the, how to write this? I keep searching for my cursor. Okay, down here. So now we are getting the probability of favorable over what? Over negative market report. Here the same thing, probability of stable over negative report. Then probability of unfavorable over negative report. So now what are we going to do with this thing? So we are going to use this posterior probability in a decision tree. How to do decision tree? Can you remember how to do decision tree? Okay, let's I shift to a blank space first. We are going to draw a decision tree using, so our decision tree, we have market research and also without market research. Without market research, how to do? Okay, let me do up the market research first. The market research, we have a box. And then market, if we do market research, this one we do the market research. Then when you do the market research, two possibilities can happen. So we draw this the decision node, sorry, and then I put here the circle. And this one can lead to two situations. What are the two situations? Positive and
negative.
And negative. So here, positive. Then the other one is negative. And then from here, each of these have three choices we are going to make. So this is the decision alternative you are going to make. What are the decision alternative? So let's look into the positive one first. We are going to produce widget.
Sorry, yeah.
Widget.
Widget.
And then nimnot, right? The last one.
Yeah.
Hammer. And then each of these expose, so that's quite tedious.
Yeah, we'll have favorable.
We have favorable Okay, we have favorable, stable,
Stable and unfavorable.
unfavorable. The same thing here is exposed to the same set, favorable, unfavorable, favorable, stable, unfavorable. The same thing for hammer. We are exposed to 3 different sets of chance event, we call it favorable, stable, and unfavorable. The same go on negative report. You have three options also. 1, 2, 3. We are going to produce widget also, widget, name node, and hammer. So the same go, we are going to write this. I'm not going to write everything. After this, I will show you straight away the pre-printed one. I just want to illustrate how to construct decision tree. So this one, widget also exposed to the same thing, favorable, stable, stable, and unfavorable, favorable, stable, unfavorable, favorable, stable, unfavorable. Okay, let's look back. This one, take note of this payoff. I would use the word widget 120 to 70, negative 30. Okay, take note. 120 favorable, 70, negative 30. I will write here. Try to switch my payoff to be written on the right hand side. What was the number just? 120, 70, and negative 30. Okay, let me look back. Hammer 60, 40, 20. 60, 40, 20. So we are going to write the payoff here. 60, no, 60 what? 60, 40, 40, 20.
40, 20.
Okay, and then the last one,
35, 30, 30.
35, 30, 30. Where is my cursor? 35, 30, 30. Okay, I don't. So the bottom one is the same. You use the same number, 120 here, 120, and exactly the same set. I just give you the idea. Okay, let's look into the probability which we worked on just now. Probability of here F stroke P here, 0.35. Are you getting what I move my cursor here. 0.35, 3.52, 0.617, 0.029. Where to write this? We are writing this one at the probability here. Here the probability is 0.352. 352. Here 0.617. Here is 0.029. 0.029. So this is the purpose of calculating. And then next one is 0.35 something. 352, right?
Yes, 352.
352.
So just copy that.
0.0?
0.617.
617. 0.029.
0 to 9.
0 to 9. So we have 3 sets now of probability. The last one is 0. The same one, 0.352, 0. Okay, never mind, you know what is going on. Okay, now let's look at the negative.
Doctor,
Yeah.
I want to ask, if we add up all the probabilities, it will not exactly equal to 1. Is that okay, or it will affect our calculations later?
I think there's a slight rounding off.
Yes.
Rounding, but it's okay for 3 decimal places. For exam, normally we expect 2 decimal places. It doesn't matter, just we are looking at how you compute. In the past, we forgive these slight deviations. Actually, the middle one should be 618. If you put 618, I think you get it almost there. The one is 0353. You just know, it's okay. If you take the first one, 0.353, 0.618,
yeah,
then exactly 1.
So how about, can we take fraction?
Can. It's tedious. Can.
Okay.
Okay, now I don't complete this one. Let's look at the second one. The second one also the same set of payoff. Here 120, here 70. This one is 30, negative 30, 60, 40, 20, and so on. Okay, let's look back. We are going to use the second set of probability. You look at the right hand side here. I am moving my cursor. Probability of favorable over n. So 0.121. Are you seeing it? Now, where to write this? So we are writing this at another branch. Here you see the negative report. Negative report. Then we write, where is my cursor here? So 0.121. 121. Here is
0.742.
74 something.
742.
742. 742. And the third one is
136.
136 or 137. 137, then we make 21. Otherwise, not.
Yeah.
It doesn't add to 1, short of 0.1, 0.001.
Yes.
So we do the same for the second set. Here, 0.121, 0.742, 0.136, 0.121, 0.7. Okay, sorry, not so clear. 0.13 something. Now from here, we are going to calculate the expected value of widget. We are going to calculate the expected value of the widget under positive. We are going to calculate the expected value, expected value. The same thing, calculate expected value, expected value, expected value. How to calculate expected value? Payoff times probability. Okay, maybe just try one of this, and then one positive, one negative. So 0.352 times 120 plus 0.617 times 70 plus 0.029 times negative 30, you will get the expected value of widget equals to, what do you get? About 84 something?
84.68.
84.68. Then the same thing, expected value for nim node. equals to about 46. You're getting this one? I think so. Expected value of hammer equals to
46.38.
here. For which one? Which one, sister? 46.3848. The last one should be 30 something.
31.7.
31.7. Okay, make it easier. So from here, what will be your decision? If the report is positive, if the report is positive, what will be your decision? Between you have these three numbers, choose which one, expected value. Take the highest widget, right? Widget. Okay, let me keep on hunting for my cursor. Okay, so we choose this one highest. So our decision will be using widget. Now we use this number 84 as if this is the payoff for positive report. So 84.68. So we do the same for the second one. Are you having any number there? About 62 something?
Doctor, still calculating.
Still calculating. So expected value of widget under this one, not
Widget is 62.38.
62.38. 62.38. And calculate.
39.66.
39.668 or 66. 68.
Six.
Okay, okay. 68. Okay, whichever. The most important, the 6 is there. The last one is
30.575.
30.575. So now, what is your decision if the report is negative? What will be your decision if the report is negative?
Widget.
Widget. Where's widget? Widget. With this expected value 62. So we write this one as if it's the payoff for the 62.38. What was the probability of positive report, negative report? Can we flash back?
Yes, the probability
Positive is 0.34.
Okay, 0.34. So positive report 0.34. Here should be the 0.66. So let's find the expected value of market research with market research. How to calculate? The same way, 0.34 times 0.34 times 84.68 plus 0.66 times 62.38.
69.962.
69.62.
962.
962. Can I round it off to 70?
Yeah.
Okay, let's do it this way. You have the idea of constructing decision tree, and then after that work backward. Decision tree construct from left to right, then After that, work backward after taking the probability. And then if we do not have the market research, okay, I do this one, straight away I do this one. This one without market research. But the payoff, this is using the prior probability, 0.2, 0.7, 0.1. And then this is the payoff, the same thing that we did just now. So calculate the expected value. We have the expected value of widget, expected value for hammer, expected value for the nim knot. Then the same thing here, we choose the highest expected value. Yeah, 70. As if it is the payoff if we do not do market research. Okay. Now, should we do the market research or not? If you do market research, you get 70. You do not do market research,
You also get 70.
Also 70.
Is it
No need.
No
No
need.
need, yeah.
Not worthwhile getting the consultant. So this is how we now I replay this one. Now I put at the bottom here. This is simplified. I already printed nicely. So this is what you have worked on just now. You get 69.966. I round it off to 70 with market research. Without market research, also 70. So, okay, let's look back at the questions. What is the question? Determine the decision strategy the company should follow. What is the strategy? No market.
No marketing research.
No market research. What is the expected value of the strategy? 70.
70.
This number, this is the expected value of the market research. Determine the maximum amount the company should pay. How much are you prepared to pay this consultant?
0.
0. And then compute the efficiency. Of course, 0 divided by EVPI. EVPI we calculate previously. Have you calculated EVPI? Not yet. We assume the probability is okay. The EVPI is 3, I think. So the efficiency is 0 over something is 0, right?
Yes.
Efficiency is 0. So forget about this guy. Okay, bad example. Okay, this one. Okay, we take some rest first. I think you are sweating, you're perspiring. You need some rest. I can give you about 3 minutes or 5 minutes rest.
Sure, doctor.
Okay, I give you 5 minutes. Then we continue something lighter. Okay, 5 minutes rest. I also need some rest. I'm looking at you. 2 minutes past.
Sir,
Yeah,
if we want to calculate EVPI, we have to multiply the probability with the highest amount for each column, right?
yeah. The highest times the probability from the first column. There are 3 columns. The first column plus the highest on the second column.
Plus the highest
I mean,
on the
probability plus the third on the probability on the third column. So to calculate EVPI, again, point 2, EVPI. No, sorry, EV with perfect information, equals to 0.2 times, not
120.
plus, not plus, times 120, not plus, this one multiply, I think I got the orientation. Then plus 0.7 times the highest, 70, plus 0.1 times the highest, with the highest, 30. Okay, what do you get?
I get 76.
76. Good, good, good. 76. Remember, EVPI equals expected value with profile information minus expected value without profile information, which is now we have 76 minus without profile information, we get 70, right? Remember just now we calculate? We calculate, yeah, here, expected value. See this one? 70. This 70. So minus 70, you get 6. Right? Remember just now, I asked you to remember this number 6. You look at this number 6. The same or not? Are you there?
Yeah, yes. So if
So
same is good. Or
so
what?
EVPI equals to minimum EOL. Okay. Okay.
Okay, ada.
Okay, break over. Okay, let's look at another questions. Okay, you are given the following payoff table. It shows the profit here and two states of nature. Use graphical sensitivity analysis to determine the range of probabilities of states of nature S1 for which each of the decision alternative has the largest expected value. I think this is also past question, one of the past question. So you have two decision alternative, D1 and D2. You have two states of nature, S1, S2. You have a payoff 10 for D1 under S1, 1 under S2. The payoff is 4 for under S1, and then 3 under S2. Then you are given, you are not given anything. So what do you do? Don't look at number B yet. Now look at question A. What should we do? Should we cry, sister? Do not know what to do? You are not going to cry. So let's say this one of them, we put the probability is P. There are only two. Just now someone rather say probability should add to 1. What is the other one? If 1 is P,
1 minus P.
1 minus P. Good. So now we can say the probability of S1 equals P, right? Probability of S2 equals
1 minus P.
1 minus P. Can we calculate the expected value for D1? Let's put the calculate expected value for decision 1.
Yes.
Yes. What is that?
9P.
10P. Oh, sorry.
Then, oh, you finish calculating, sister. We are
10P
9P plus
1 minus P.
1 minus P times 1. 1 times 1 minus P. So sister already get 9P. What is that? 9P plus 1. Right, sister?
Yes.
9P
Yes.
plus 1. That's how you say. So can we do, no, you are very fast. I am behind you already. Expected value for D2. For
P plus
P
3.
plus 3, 1 minus P. Then equals to
P plus
P plus
3.
3. Now what? Let's plot a graph. So this is a graphical sensitivity analysis. Let's plot a graph. Let's say we have this vertical line as the expected value. Here, let's say put EV, expected value. And then somewhere across is the probability, P. Where's the range of probability? 1, right? 1.
Yes.
0 to 1. 0 to 1. Let me do dot. You want to plot. We are going to plot the expected value profile. Now let's use the D1 first. If P is 0, if P is 0,
1.
1. Okay, let me put it 10 up here, 5 here, 1 somewhere here. Okay, put it Then if P is 1,
10.
10, somewhere here, right? If P is 1, it's somewhere here, I put here. Then what do you do? Linear equation, right? So we are going to draw straight line joining the 2 points. So this is the profile for expected value for D1. Can we do the second one?
Yes.
Yes.
Yes. If P is 0,
3.
3 somewhere, maybe somewhere here, more or less there. Then if P is 1,
4.
4. Also somewhere, I don't know, somewhere here. Okay, just estimate. Now, just plot the line. Oh, okay. So now if from, okay, let me write first, expected value, this expected value for D2. Now, from this point to this point, what will be your decision?
D2.
D2.
From here to here, what will be your
D1.
decision?
D1.
D1. Now,
D1.
okay, now from here to here, what is this here?
The intersection, we need to find the
Intersection. You have to find out the value of P at this point, right? At this point.
0.25.
Okay, you are done already. Anybody wonder how does this magic number come about, 0.25? Are you okay?
Yes, Dr. We know.
Just
Okay,
equate
you know,
the
equate
two.
9P plus 1 equals P plus 3. So now, at what value of probability that your decision will be the most sensitive?
0.25.
0.25. So if anything between 0 to 0.25, you will decide D1, right?
Yes.
D1. And then from 0.25 to 1, you will decide on D2. D1, D2. Easy, right?
Sir,
Yeah.
between 0 and 0.25, is it D2 or D1?
D2.
Thank you very much.
Welcome, sir.
Okay. So this is not right, not right. Where is my pen? So here D2, D1, D2, D1. Good. Okay, now are we okay? We are done with question 1. Actually, we are done with question 1. Now the next thing is suppose P strong demand is 0.2. Of course, understood. If 0.2, the other one must be 0.8. What's the best decision? If 0.2 somewhere here, what's your best decision? Somewhere here. How to answer?
D2.
D2. As simple as that. But unfortunately, many students get confused in the past on this one. Now I create my own question. If PS1 is 0.8,
D1.
D1. 0.5,
D1.
okay. So easy, right? Very easy. So this one, in case there is it come out in the exam, you should know how to handle it. No, the last one is perform sensitivity analysis on the payoff for decision alternative D1. Actually, you already did it. So this one actually you have done just on indirectly. I'm asking you a question. At what probability value is your decision most sensitive? You already answered these questions. Okay. We are not going to do anymore. We just browse through something. Just now we spent a lot of time calculating the probability of, calculating the posterior probability. This time, let's look at these questions. I don't read out the questions, but maybe you can try on your own. In this scenario, you are given these probabilities. Do you notice anything? Oh, past questions. What do you see this one? This is conditional probability. Still conditional probability.
Yes.
What is this thing?
It's posterior.
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 Posterior, right?
Posterior.
You see the small s, the small one on the left hand side. Here, the s also on the left hand side. That means indirectly, let me scroll backward. So indirectly, this information is given. See this one, the format. You are given these posterior probabilities, and you are given these probabilities. Okay. So situation like this, you don't have to worry about calculating. What you do, you draw the decision tree straight away, and then just insert the probabilities into the decision tree, and then make your decision. Okay, maybe we just, for fun, a few minutes. So we have 1, 2. 2 decision alternative, 3 states of nature. Okay. Are you there? Okay.
Yes, yes.
Okay, so let's, can we draw a decision tree quickly?
Sure.
Here. So we have 2 decision alternative, 1, 2. And then each of these are exposed to how many states of nature? We have chance node, we call it the circle, chance node. We have 3 states of nature. So here D1, produce the series D1, D2, up to you to write. You want to write produce pilot, cell, whatever. Then you have this states of nature S1, S2, S3. This is the same S1, S2, S3. Then write down the payoff. Here negative 100, 50, then you make 150. The next one, you are selling the same price in all conditions, 100, 100. So this is a situation if the probability given there 0.2, 0.3, 0.2, 0.3, 0.2, 0.3. Do you know where I get it from? Here. Given you 0.2, PS2, PS2 given. Then you can calculate the expected value. 0.2, 0.3, 0.5.
First one is 70.
This one is
70.
70. 0.7. The same one is 0.2, 0.7, 0.3. So the decision, second one, 100, is it?
Yes,
Is it
100.
100? Because anything time, because all 100. So your decision,
D2.
D2, sell. You produce instead of waiting for the TV. So decision will be D2. Your payoff, no market research, 100. So we are going to branch out if we do the market research. Okay, see downstairs, this one. So here you can do, you have two situations, favorable and unfavorable, P and U. Sorry, yeah, F and U. Yeah, yeah. Assume an agency, they want to have an agency. The probability is favorable or unfavorable, the two sets. So you're going to have another set of decision tree. This one continuation from the top just now. Let's continue this one. What did I say? Okay. From here, this one without agency. Now down here is with agency. Okay, we continue here with agency. So what happened? So you are exposed. Sorry, I should put a second. You are exposed to two situations. What are the situations?
Favorable and unfavorable.
Favorable and unfavorable. We do the same from here. We have branch out exactly the same thing. I think you will know what to do already. Branch to two decision. D1, D2. You also D1 and D2. D1, D2. D1, D2. Then you are given the probability. Of course, the payoff, you know what to do. So you are given already the chance event. So now we are having three possibilities. Chance event to three possibility. Same thing here. So you do exactly the same. Then after that, work to the left. You know what I mean? That, are you getting what I mean on these three possibilities?
Yes.
S1, S1, S2, S3. Again?
And the EV.
Yeah.
Yeah.
S1, S2, S3, right? The three here. This is S1, S2, S3. And then you put the payoff there. S1, S2, S3, S1, S2, S3. S1, S2, S3. And then you write the payoff. You write the probability. Now you have the probability S1F. What is the probability of F first? So you are given
0.09. Oh, sorry.
0.669, right? Yeah, we are given on the
Yes,
Oh, okay.
0.69 for favorable.
here this one. Unfavorable 0.31. 0.31. Then you are given this set of information used for the top branch. So here the probability will be 0.09, 0.26, 0.65. Here the same 0.09, 0.26, 0.65. So this is under favorable. And then the next one, we are looking at this one, this set. Unfavorable, look at this branch. This branch. So you put the probability, where's the top one? Cannot see. I can only see the last two numbers, 0.39, 0.16.
0.45.
0.45, yeah, the top one.
Yeah.
0.45. So you do the same, 0.45, 0. Whatever number. Then write down the payoff on the right hand side here. The payoff, the payoff. So this one will be faster because you are given the posterior probability. Okay. And this one you can do on your own. But in your investment, you have 10,000. Bear and bull market. Where should you put your money? Okay. Okay, brothers and sisters, I think you can put in chat your attendance, your metric number. Can you see me?
Yes.
Yes.
Okay. I think we enjoy ourselves today, I suppose.
Very much.
Very
Yes,
much.
teacher.
But my apology because I wish if we have proper class, I will use the board, and now I'm using this board, so I had difficulties in writing. Okay, I think we end our day today. So meanwhile, can you put in your chat? Okay, let's end our day with the recitation of Surah As. Bismillahirrahmanirrahim. Thank you very much, brothers and sisters. See you next
Thank you,
class.
Doctor.
Yeah,
Thank you
most
very
welcome.
much, teacher.
Most welcome.
Thank you, doctor.
Thank you,
Most
doctor.
welcome.
Thank you,
Yeah,
that
most
one
welcome.
teacher.
Yeah, who's that little one?
Thank you, doctor.
Thank you,
Okay, most
doctor.
welcome. Yeah, most welcome.
Thank you, Doctor.
Mm.
Assalamualaikum.
Okay,
Thank you, Doctor.
Wassalam. Most welcome. See
Thank
you
you,
someday.
doctor.
Okay, I'm ending the meeting now for everybody.